reducing atmosphere. And they applied an energy source to drive the organic compound synthesis. And they built this apparatus to simulate the early Earth. And their idea was you put the ingredients in, you turn on the electric spark, wait a few days, and in the end it would produce the building blocks of life. And they really expected to see just about every possible organic molecule come out of this. Now, what are reducing conditions? If we imagine that the foremost, well, we don't have to imagine, we know the four most important elements to life are hydrogen, carbon, nitrogen, and oxygen. In a reducing atmosphere, the hydrogen would be in the form of molecular hydrogen. It would be a gas. Carbon would be in the form of methane. Nitrogen would be in the form of ammonia. And oxygen would be in the form of water vapor. Our current oxidizing atmosphere, hydrogen is in the form mostly of water. There's some trace levels of hydrogen, but these are being continually produced, and they're rapidly consumed. Carbon is in the form of CO2. Nitrogen is the molecular nitrogen gas, and oxygen is molecular oxygen gas. So what Miller and Urey did is they used this reducing mixture. And this is the apparatus they designed. It has a large flask, a 5-liter flask, where they had their atmosphere. There were the 2 tungsten electrodes to make the spark that would simulate lightning. They had a condenser to simulate the cloud-forming processes in rain. They had a little trap here that would be filled with fresh water condensing from the large bulb. This would be like the freshwater streams running down the sides of the continents. And then they had an ocean here where they would be drawing their samples out, where the organic compounds should collect if they were formed. And they heated this flask so that the water vapor would go back up and circulate, and this would go around and around. And when they did the experiment, they really did find all the building blocks of life. They found amino acids, they found fatty acids, not real long-chain ones. They found things like acetic and propionic. They found many of the nucleobases that you need for RNA and DNA, and they found some small sugars. But if you read Miller's papers very carefully, you'll also notice that he mentions this oily red goo coating the walls of his apparatus. It turns out this is the major carbon product of the experiment. But most people don't concern themselves with it because it's not one of the building blocks. These are what they were interested in, they focused on, and they just sort of ignored this for years. We'll come back to this later.